Section 4.4 kind of begins factoring, which is going to be the next several sections in the book. So the two big things in section 4.4 are factoring out a greatest common factor and then factoring by grouping. And even when we get into the next stuff, like when we get into 4.5, 4.6 and the type of factoring that shows up there, if there's a greatest common factor, you always want to get that out first, because then what you're going to be left with is going to have smaller numbers and smaller exponents, and it ought to be easier to handle. Factoring by grouping, it's the first one that we're going to do that's more of like a specific technique where it's, if it looks like this, then you want to factor by grouping. The nice thing about factoring by grouping, it's easy to catch because it has 4 terms, and everything else that we're going to do does not have 4 terms. So that's the thing to look for. But factoring out the greatest common factor, we'll start there first. You want to factor out the biggest polynomial you can in a general sense, but really usually that means you're factoring out a monomial. Not always, but the vast majority of the time that's what it is. Sometimes you can factor out something that's actually like a binomial or a trinomial, like if it's written with products, like this thing that's here in parentheses. So like this right here. You could factor a 3x minus 1 out of that because it's part of this first product and part of the second product. So there you can factor out something that's not a monomial. So sometimes you can do that. And that's actually a maneuver that's part of factoring by grouping. But if you're just, right off the bat trying to factor out a greatest common factor before you do anything else, then in most cases it's a monomial. And then this thing about having the negative coefficient on the leading term, we'll get to that in a little bit when it actually shows up. I think it shows up at the beginning of page 2. So factoring out the greatest common factor, what I would say is look at I kind of go piece by piece. I kind of go coefficient, then variable, and see what I can factor out. Or if there are multiple variables, it's coefficient, variable number 1, variable number 2, right? That kind of thing. So here, this first one, the variable is only in the first term, so we're not going to be able to factor that out, right? There's nothing that's common to both in terms of x. But with the coefficients, we got a 4, we got a 20. Those are both divisible by 4, right? So you could say, well, then this is 4 times x squared plus 4 times 5. So I'm just writing it so the 4 is part of each of those products. And then we can factor it out. So going from what I've got here to what I'm about to write is like the distributive property, but backwards, right? Where instead of distributing to each term, I'm taking that 4 away and pulling it out front, which you can do, right? I mean, the distributive property is an equality, so you could go in the other direction if you wanted to, and here that's what we're trying to do. That's what's actually going to help us. So if we factor out the 4, then what we're going to be left with from the first term is an x squared, and what we're going to be left with from the second term is a 5. So that's what it would look like factored. All right, so then here, I guess I didn't write it out, but what we ended up with for the greatest common factor was 4, right? Because that's what we factored out of both of those terms. Here, it's going to be a multi-step process, so we'll see what we get. With the greatest common factor, all right, coefficients 12, 15, and 30. Those are all divisible by 3, but nothing bigger than that. So 3 is going to be part of this. And then we've got an m to the 5th, m to the 4th, and an m squared. Generally with variables, if you can factor something out, it'll be the smallest power of, or smallest exponent that shows up. So we had m to the 5th, m to the 4th, and m squared. We should be able to factor out an m squared. So that's going to be our greatest common factor that we're going to factor out here. And we're going to write this as, so the 12m to the 5th, we can write that as 3m squared times, and then we just have to figure out, what do you multiply 3m squared by to get that 12m to the 5th back? Well, 3 times 4 would give you that 12. And then to get the m to the 5th, you would need an m to the 3rd, right? Because then you can add the exponents, and 2 plus 3 would be 5. All right, next term. If we have the 3m squared factored out, so what do we multiply 3m squared by to get 15m to the 4th? Well, 3 times 5 would give us the 15, and then m squared, right? Because then m squared times m squared will be m to the 4th. Last one, so 3m squared times what will give you 30m squared? Looks like a 10, right? Because 3 times 10 will give you 30, and then you already got the m squared. right? So that's already taken care of. And then if you factor out the 3m squared, first term, you're left with the 4m cubed. Second term will be a minus 5m squared. And then the third term will be a plus 10. And so there we go. Okay, number 3, same sort of idea where we can get the greatest common factor first. So let's see, coefficients, 14, 7, and 21, all divisible by 7, right? So it looks like 7 is going to be part of the greatest common factor. Then for the x's, we got x to the 7th, 6th, and 4th. Should be able to factor out an x to the 4th, right? Smallest power of x that shows up. And then for the y's, we got 7, 3, and 2 is the exponents. So we should be able to factor out a y squared. All right, so that's our greatest common factor that we are then going to factor out of each of those terms. So, all right, 7x to the 4th y squared. What do we have to multiply by that to get the 14x to the 7th y to the 7th back? 7 times 2 would give us the 14. Then we'd need x to the 3rd, and then we'd need y to the 5th, right, to get those exponents of 7 up there. Then let's see, minus, well, all right, 7x to the 4th y squared times, I guess you could say 1 here, right, because 7 times 1 will give you that 7. So 1 x squared y, or just x squared y. I guess you don't really need the 1 if you're multiplying. And then minus 7x to the 4th y squared times, all right, 7 times 3 would give you the 21. X to the 4th y squared, that's all taken care of already. So what we're going to end up with is 7x to the 4th y squared times, let's see, from the first term, you got 2x cubed y to the 5th, then minus x squared y minus 3. Okay. Now, what if you have a negative? All right, so if I go back up toward the top, when the coefficient of the leading term is negative, you factor a negative number out as part of the greatest common factor. This is one of those things where if you don't remember it, it becomes like a gray area where you think like here with the negative 9b plus 72, you think, should I be factoring out a 9 or a negative 9? I don't remember. But if the leading term has the negative coefficient, you should factor out a negative. So here we're going to factor out a negative 9 because that's our leading term, right? It's got the highest power of b in it. So we'd have negative 9 times b, and then plus, I guess you would write that 72 if you factor a negative 9 out as negative 9 times negative 8. And then you can write this with the negative 9 factored out, and what you'd be left with is b plus negative 8, right? B from the first term, negative 8 from the second. But most people write that thing inside the parentheses as b minus 8. So negative 9 times b minus 8. Number 5 is the same concept because the one with the a to the 5th in it, that's the leading term, right? It's the highest power of a. But the coefficient's negative 2. So we've got to factor out a negative 2a, it looks like, right? Because the smallest power of a that shows up in there is that a to the 1st. So we could do that. So you have negative 2a times a to the 4th, right? Because multiplying by a to the 4th will give you that negative 2a to the 5th back out. And then plus negative 2a times, let's see, I suppose we'd have, and it would be, actually, this will be easier if I write this as a minus. You could write it with a plus, but it'll be easier with a minus, I think, just to see what's going on. So if you factor a minus 2a out, then you'd be left with minus 5a squared, right? Because negative 2 times negative 5 will give you that 10. A times a squared will give you the a cubed. And then plus negative 2a times negative 2, right? Because negative 2 times negative 2 will give you that 4. And that a is already in there. It's taken care of. So then you could factor the negative 2a out. and you'd be left with a to the fourth, the first term, then minus negative 5a squared, and then plus negative 2. Or, to use the more conventional way of writing this, I guess I have to write it over here where I have enough room. Negative 2a times a to the fourth plus 5a squared minus 2. Right? That would be, I think, the more conventional way to write that thing inside the parentheses. All right, so if you got the negative coefficient from the leading term, factor out a negative when you're factoring the coefficient out. Then 6 and 7 are ones where you can factor out a binomial. 6 is almost comically short. It's so short that it feels like a trick. Because x minus 1 is a factor of this first product. It's also a factor of the second product. So in the first step, you could just factor it out. And if you do that, then let's see. Well, then from the first term, you'd be left with a 3y. And then from the second, you'd be left with a 4. Done. That's the entire problem. So that's what I meant when I said it's so short that it feels like a trick. That's really all you have to do, because x minus 1 is clearly a factor of both of these, right? You got two products where it's x minus 1 times something else. So you could factor the x minus 1 out right there and just be done with it. Number 7, we're going to kind of do the same thing, except that here we have a 6x plus 1 quantity squared. So we are going to factor the 6x plus 1 out. And then what we're going to be left with, and I guess I need brackets because I'm going to have two sets of grouping symbols. We're going to have a 2x from the first term, and then minus 5 times 6x plus 1 from the second. So why do I have a 6x plus 1 here? Well, it's because originally it was a square. So when the 6x plus 1 is factored out here, that's one of them being factored out, but the other one's still there. So that's why I've got the 6x plus 1. And then I guess I can distribute the 5, distribute the negative, and then we'll kind of see what we end up with here. So 6x plus 1 times, if I distribute the 5, I'll have 2x minus, let's see, 30x plus 5. And then distributing the negative, I guess that would be the next thing. So we'd have 2x minus 30x minus 5. And then we could combine terms and say, well then, this is 6x plus 1 times negative 28x minus 5. And to me, this is far enough. But I saw something in our book where they had a similar kind of answer, and they rewrote it where the coefficients of the x's were all positive and basically just pulled the negative out front. So you can do that. And I guess I'll change colors just to indicate, like, in my world, that's done, right? Like, that's factored as far as you can factor it, and it's simplified as far as you can simplify it. But you could bring the negative out front if you wanted, because you could just factor a negative 1 out of that second binomial, and then that'll just flip the signs around, right? If you distribute a negative, that changes all the signs. If you pull a negative back out, that also just changes all the signs. And then you could put the negative 1 out front, right? Since this is multiplication, you can do this in any order you want. So that's what we can do. We can bring that negative 1 out front, or you could just write it, and this is what the book had. Instead of having a negative 1, it just had the negation of 6x plus 1 times 28x plus 5, something like that, which is fine, right? I mean, multiplying by negative 1 is the same thing as having just that negation out front. But the part that's in green, I don't know that that would be necessary on the homework or not, and that's why I wanted to bring it up, because as far as I'm concerned, like if it's just me doing it, I think that's the end of the blue is where it's done. But you can factor that negative out if you want to. And since it showed up in the book, I thought, well, the homework's usually pretty consistent with the book, so it's worth bringing up. So if you get something like that, and if you try to put an answer in like this and it doesn't work, then factor the negative out. I guess that's really what I'm trying to say. All right, the other thing in this section is factoring by grouping. And I said that was easiest spot because when you have to factor by grouping, it tends to be when you've got 4 terms. So like it says right here. So 4 terms with a greatest common factor of 1. That's when factoring by grouping is going to be the thing that you want to do. So in other words, you hit a point where you couldn't really do anything, like you couldn't factor anything out of all 4 of them. Like just look at number 8, right? You say, well, you could factor an R out of the first 2. Yeah, you could, but you couldn't factor an R out of this one, you couldn't factor an R out of this one. There's nothing that's common to all 4, right? 2 of them have R's, 2 of them have 3's, 2 of them have X's, 2 of them have Y's, but it's not the case like all 4 of them have a coefficient divisible by 3, because the first 2 don't, right? Like there's nothing you can factor out of all of them. So this is where factoring by grouping comes in handy. So the way that you do it, you group the first 2 and the last 2 terms, usually with some kind of grouping symbols like parentheses. I guess if you really felt like using square brackets or curly brackets instead just to do something different, you could. It would be unorthodox, but you could do it. And then at that point, you're going to have 2 binomials, like one in each set of parentheses. You can factor the greatest common factor out of each one. And then from there, it'll actually look like number 6, basically. And then the other thing is you can rearrange the order prior to doing the factoring by grouping if you want to. That's not really helpful for number 8, but there are situations where it is. So what I'm going to do, the first thing is to group the first 2 and last 2 terms. So I'm going to put the first 2 inside parentheses. Then I'm going to put the last 2 inside parentheses. And then I'm going to try to factor out of these 2 binomials. So this first set of parentheses, both of those terms have an R. So we could factor out the R, and then we'd be left with X plus Y. And then the second one, both of them have a 3. We could factor that out, and we'd be left with X plus Y. And look, this is just like number 6 that we had before. We've got 2 products where in each case it's X plus Y times something else, right? It's the same binomial. So we could factor the X plus Y out, and then we'd be left with R from that first product and a 3 from the second, and that's the answer. X plus Y times R plus 3. So that's how you do it. And you'll know when it's factoring by grouping because there will be 4 terms. Right? When it's that's when you want to think this is probably going to be factoring by grouping. So once again, number 9, we got 4 terms, and we're going to do the exact same thing. So we can rewrite this with the first 2 grouped together, so 2a cubed minus 7a squared. And then the last 2 grouped together, so plus 10a minus 35. All right, well then in this first group, those coefficients, we can't really do anything with them. They don't have any common factors other than 1. But then we got an a cubed and an a squared, so it looks like we can factor out an a squared. And if we do that, then in the first term, we'd be left with a 2a. Second term, we're left with a 7. And then if we go down here, we can't factor any a's out because we just got a constant here, but 10 and 35 are both divisible by 5. So we could factor a 5 out, and we'd be left with 2a from the first term, and then minus 7. Oh, look, 2a minus 7's in both. So then we could factor that out. And then from that first product, we're just left with a squared. From the second one, we're left with 5. There's the answer. 2a minus 7 times a squared plus 5. Another thing I wanted to point out, like about the order. So just going back to what we have, I'll do it in black, like up here. You could do this one if it was Rx plus 3x plus ry plus 3y, right? It's the same terms, just in a different order. And that would still work, right? Because then you'd say, well, then this is going to be Rx plus 3x plus ry plus 3y. And then the first grouping, you're going to factor out an x. So you have x times r plus 3. Second one, you can factor out a y. So you'd have y times r plus 3. And then r plus 3 is a factor of both of those products. So you'd have r plus 3 times x plus y. And I guess these came out in the opposite order, but that doesn't really matter, right? I mean, it's multiplying, so you can multiply in the opposite order and get the same thing, right? 5 times 2 is 2 times 5, right? There would be an order that doesn't work, right? Like if you had, let's say, if I put the Rx and the 3y as the first two. Like if you had this, you couldn't do anything the way that they're currently arranged. And this would be a situation where you'd want to rearrange the order, right? Because the way it is now, it doesn't work. So you think, well, either I need to put the 2 with R's in them next to each other, or the 2 with X's in them next to each other, or something like that, right? But yeah, like, see, you can switch the order around and you'll still get the same answer. The point where that might be advantageous is not in either of these, but it's in number 10. Because in number 10, if there's anything that tends to cause trouble with factoring by grouping, it's this right here. It's when you have a minus right in the middle of the polynomial. Because what you're supposed to do with that, and this is really easy to forget, like this is a really common mistake to make, I've certainly done it before, but what you're supposed to do when you group these is to write this as 15x squared plus 20x, and then plus negative 9x minus 12. So you bring that negative along with that 9. You could leave it with a negative in there, but then you have to remember to switch the sign on the 12, and that's a hard thing to remember. So it's easier just to say negative goes with the 9, and you got to have a plus in between the groups. So if you just think that when you have your groups that you have to have a plus in between the groups, maybe that's the best way to look at this. So I'll put that in here. So that thing, let's say you need to have a plus between the groups to get this to work out right. Okay, well then if we do it, this will work just the same way it did before, where we look at these two coefficients and we go they're both divisible by 5. We can factor out a 5. Then x squared and x, we can factor out an x. So 5x times 3x would give you the 15x squared. And then 5x times 4 would give you the 20x, right? Then plus, and then here, remember, when you're factoring and your leading term has a negative coefficient, you should factor out a negative. So then here we could factor out a negative 3, right? Since 9 and 12 are both divisible by 3, but this leading term has a negative coefficient. So you factor out a negative 3. Negative 3 times 3x would give you the negative 9x. And then negative 3 times 4 would give you the negative 12. And then, oh look, 3x plus 4 is in both of these. So you'd get 3x plus 4 times 5x plus negative 3, or I guess written the more conventional way, 3x plus 4 times 5x minus 3. Okay, that is the right answer. And where I said there would be an advantage to rewriting things, what if whenever you see the minus in the middle, you just think, you know, weird things happen when that's there, and I don't remember exactly what to do? What you could do instead is say, well, what if I just rewrote that? So we've got 15x squared plus 20x minus 9x minus 12. What if you just said that's equal to 15x squared minus 9x plus 20x minus 12? All I did was interchange those middle terms, but look, now I've got a plus in the middle. And this actually is going to feel a little bit simpler, because then your groupings are going to look like this. So to me, this feels a little bit simpler. When I get these with the minus right in the middle, I always do this. Even though, yeah, you can do it and you just keep the minus with the 9, but I always just flip them if I can. And then go, aha, now I have a plus in the middle. And so now that's one less thing I have to worry about. And then I could factor a 3x out of that first grouping, and I'd be left with 5x minus 3. And then I can factor a 4 out of the second grouping, and I'm left with 5x minus 3. And I am going to get the same answer, right? I'll have 5x minus 3 times 3x plus 4. And there we go. Done. All right, so there are options, is what I'm saying. So like this one that's in black, that's basically all I'm saying is there are options. If what you have to do here feels a little bit awkward, just remember that you can do this, that it's okay to flip the order around. And then if you have a plus in the middle, that probably does feel easier. It feels that way to me, so I'm sure I'm not the only person that thinks like that. But that would be everything in 4.4. So this one's not too long. 4.5 might be an epic. I'm not sure yet. I haven't written up a blueprint for it, but I have that feeling that that's what we're going to end up with. So this one wasn't too long, but the next one might be. We'll see.